Hi everyone, welcome to Eve Math Tutoring. Today's lesson is on converting numbers into scientific notation. So I'm just going to first give you an example of what a number in scientific notation would look like. So an example could be 1.5 times 10 to the 11. So usually what you'll see with a number that is in scientific notation is you'll have one digit on the left other than 0, and then decimal may follow or may not follow with other digits. And then you'll have some times 10 to a power of a negative or a positive number. So all numbers in scientific notation look similar to this here. Okay, so we're going to try some examples. And we usually use scientific notation in chemistry. Okay, it's used a lot in chemistry. Now, say you're given an example and you have a number given to you in standard form, and you're asked to convert the number into scientific notation. Okay, so say you're given 346. So what you do is, basically, whenever you have a number, the decimal is always at the end of the number. Even if it's not written down, it's always at the end of the number. So what you do is you actually take this number, and you take the decimal, and you move it over to the left twice. So you want the decimal to be after the left utmost digit, which is not 0. So then that becomes 3.46. Now, because I made this number smaller, I now have to accommodate for that by multiplying by 10 to the power of 2. However many times I move the decimal to the left, that's what I raise it to the power of. Okay? And to remember if this should be positive or negative, you can remember that if you make the number smaller, you have to make the exponent larger, because these two are still the same number. Okay, the only thing is that this is in standard notation and this is in scientific notation. That's the only difference. They're still the same number. Okay, so let's try a few more examples. So say you have 2700. So again, you take the decimal, which is at the end, and you move it over. So in this case, we had to move it 3 times. So 2.7. You don't have to write in the zeros here. Times 10 to the positive 3. And the reason I make this positive is because I made the number smaller here. So I have to adjust that by multiplying by 10 to the 3. And I know this is the correct answer because if I took 2.7 and multiplied by 10 to the 3, which is 1,000, so it would be 1 with 3 zeros attached, that would move the decimal place 3 times to the right, which would give me this number. So these two are in fact equal. Okay? Let's try a bigger one. So 34720. So again, the decimal is at the end of the number. So I go 1, 2, 3, 4 until I get to the left utmost digit, okay, other than 0. So in this case, I had to move it 4 times to the left. So I write 3.472. Don't need to write the 0 times 10 to the 4. So that's converted into scientific. Okay, I'm going to show you a few examples of numbers that are less than 1. Now, say you're given something like the following. Okay, so if I want to convert this number into scientific notation, what I'm going to do is I'm actually going to move the decimal place over this way. So it becomes 8.2217 times 10 to the, and because I made the number bigger here, I have to make this part smaller. So I moved it to the right by 1. So this becomes -1. So this is like multiplying by 0.1 will give me back to this, okay? So because I made the number larger, I make the exponent smaller. So that's how I know I have to use a negative there. Okay, we're going to do a few more examples. Okay, let's do 0.0035. So in this case, I move the decimal over to the first digit that's not after the first digit, which is not 0. So that's going to be 1, 2, 3. So I get 3.5 times 10 to the, because I made the number larger, I have to make the exponent smaller. And I moved it over 3 times, so this becomes minus 3. Because I moved the decimal to the right, I make the exponent by 3 units. I make the exponent 10 to the negative 3. So it becomes negative 3. Okay? So if you move it to the left, if you move the exponent to the left, you're going to raise your exponent to that positive power. If you move it to the right, you're going to raise however many units you moved it to the right by in a negative number in your exponents. So let's try. Okay, so this one we would have to move it over 2 times because we want to reach a number that's other than 0. So that's going to be 7.75 times 10 to the negative 2. Okay, so that's how it works. So that's converting numbers that are smaller than 1 into scientific notation. And of course, if there was a negative in front, you would just attach a negative in front of the number here, and same thing goes for the previous page, okay? So that's converting numbers into scientific notation. All right, I hope you enjoyed